So the initial goal of my research was I wanted to build some tool that helped in the instruction of programming courses. Typically in programming courses, if you want to get help in the course, you kind of self-select and say, I need help, go to office hours or something like that, and your professor helps you out. So that's problematic because people don't necessarily know when they're having difficulty. It's actually really common in industry and in education, or they're not comfortable going to office hours, or sometimes people think they're in difficulty and they're actually not. People would figure out problems on their own, but they go to office hours the second they hit trouble. So we need a better scheme. So this is kind of the workflow I initially had in mind. We have, I was originally planning on doing this in Eclipse since it's so popular in this department and elsewhere. We have a plugin in Eclipse that's collecting information about the program environment, such as editor contents, console contents. It also collects information about the student. Either it uses difficulty detection algorithms, which are just machine learning things, or it has students self-report how much trouble they think they're having. It relays that to the instructor, and based on the information, the instructor can see who they want to help, and it has some tools for allowing that collaboration, such as instant messaging or shared editing capabilities. So the first thing I noticed thinking about this is that there's no reason this has to be bound up to Eclipse. Lots of this stuff isn't Eclipse specific at all. Of course, some things are, like actually capturing the other contents. That's something that's going to be environment specific. But in general, doing difficulty detection, these communication mechanisms, all this stuff isn't Eclipse specific. So the implementation I come up with should account for these other scenarios. Continuing in that line of thought, this workflow is actually more general than just programming scenarios. So there's general collaboration that looks a lot like this. We're collecting information from some subject's environment, information about the actor themselves. We want to feed it to some server that does anomaly detection on it, and then based on anomalies, alert some kind of observers, and those people will collaborate in a loose notion with your actor. So take the example of fitness trackers. We have, instead of a computer programmer, someone who wants to be more healthy, more active. So their desired state isn't a correct program, but a healthy life. And instead of an instructor, they have maybe a support network of coaches, friends, and so on that want to help them achieve that. So the fitness tracker kind of detects anomalies in their activity levels, notifies these people, and these people collaborate. My point here is that the collaborative system I'm building, while I'm building a specific instance, it's kind of lots of the subsystems involved are applicable in these other scenarios, and the system should be designed such that it's easily extensible to handle these other scenarios. This example is cool because it has a feature that isn't obviously present in the programming example, and that is the actor is in one loop, so the walker down here, while an actor in its own loop is an observer in someone else's loop. So you may be trying to live a healthy lifestyle, but at the same time you're also watching your friends try to do the same. So this is interesting because this can be directly laid on top of the programming example. Perhaps students being aware of each other's programming activity can drive everyone closer to their desired state of having correct programs submitted on time. I have some videos to show you all. They're clips from a longer video, so I apologize if they seem kind of out of place. This one demonstrates, I just want to give a more concrete example of the system I ended up building so you have something in your mind when I talk about the rest of this. And it also shows this idea of networked loops I just talked about.
Let's look at several things Hermes currently does. It provides a simple UI where students can self-report the difficulty they are experiencing, as well as explicitly request help. Additionally, the Hermes server has an extension which allows it to publish to a course Facebook page. When a student requests help, a message is posted on the page's wall, which is visible only to instructors, with the student's information and help request. By looking at the page's feed, an instructor can quickly see who needs help and proceed to gather information to help them. The ability to post to Facebook also allows for useful information to be displayed to students. By aggregating the reported degree of difficulty students face, difficulty versus time graphs can be constructed for the current assignment, and students can see how much trouble their peers are having. If an assignment looks to be hard, students may be motivated to begin early. Also, the simple knowledge of how many of their peers have begun work on an assignment may be enough to prod students to begin earlier. In the same manner that fitness watches have adopted the same concept of status timeline to encourage healthier lifestyles in their users by showing them the activities of their friends.
Okay, so generalize this even further. That actor doesn't have to be a human person. So this is a project that's going on at UNC right now. You want to detect faulty HVAC units. This is the same kind of collaboration workflow I showed earlier. So this is a really general collaboration workflow. So the system I want to build, while the problem it's tackling is facilitating programming education, we also want to have this goal of proportional reuse. So the system should be reusable in these other scenarios to the extent that they are similar. So all the ones I just described are examples of opportunistic collaboration scenarios. We have some trigger that begins the collaboration, then they have tools for that collaboration, such as these communication schemes, and so on. And so those tools should be reusable. They should be modularized out of the implementation enough that these other applications can use the same collaboration implementation I have in my goal system for their systems. And similarly, so the programming scenarios, they should be able to reuse all those tools. So the difficulty detection I use for Eclipse programming, that should be able to be reused in IDE1 programming without any modifications. Related to this is kind of the converse of the point I just made, is so a lot of these things like facilitating collaboration, that's been implemented many times over. We have instant messaging clients, we have shared editing tools, we have some great tools for collaboration. We should leverage those tools. We should build on top of them. And this is related to my final goal, scalability. We want internet scale collaboration, because this is great. We want someone in North Carolina to be able to help someone out in Texas. You can see how well this works by looking at any online programming forum, such as like Stack Overflow. We get great results when we put a lot of people together trying to solve each other's problems. And this is closely related to the goal of interoperability, because if you want that type of scale, you have to have pretty robust systems, and those are challenging to write, too challenging to write for an undergraduate thesis, so we should just use other people that figured it out, like Facebook. Facebook knows how to do this internet scale networking between users. So this is just the abstraction I've been hinting at. This kind of scenario has been described by my advisor, Professor Dewan. This is the general workflow. This encompasses all other ones. So the system I'm building is trying to provide an architecture to support this workflow and an implementation of that architecture. We can talk about this at the end because it'll take time, but this is basically the architecture I came up with that supports this goal of proportional reuse. So this architecture is modularized to the extent that these pieces that can be used in different places, they're able to be used in different places. I have another video for you all that shows how I went about having a notion of history. So for the programming scenario, you need some concept of what the student's workspace looked like throughout time, so you can help diagnose their problems. In other cases, this notion of history is very useful as well. So the way I solved that problem was using Google Drive.
Hermes collects the text in the code editor and tracks changes to it. The server uses this information to create a Google Doc, which mirrors the file in the student's editor. Both the student and the instructor have access to this file, provided the student allows this. Here we again see the power of leveraging existing technologies. Because it is a popular platform, a number of extensions exist to manipulate Google Docs. By interfacing with it, Hermes gains access to all the features offered by these extensions, in addition to all the features already built into Google Docs. For example, there's an extension called DraftBack, which allows anyone with access to a Google Doc to peruse all historical changes to it. If an instructor wishes to see where a student ran into trouble, they can open the file of interest and look at recent changes to it. As another example, Google Docs provides the ability to add comments to a document, which are shared between viewers. At the end of an assignment, an instructor can provide feedback in the form of comments from the Google Docs corresponding to the code the student wrote for the assignment. In addition, Google Docs has a mobile application, so all of this information can be viewed on the go.
Implementation details, again, we can talk about these later. So the architecture tackles the problems of proportional reuse, but not the two problems of interoperability and scalability. Those are ultimately implementation issues. And I tackle both of them just by interoperating as much as possible, since, as I mentioned, a lot of these problems have been solved, so this is mostly stitching together these existing solutions. This video shows some scenarios I had in mind for what the system can solve and what the system can solve that I ended up building.
Hermes provides a communication system that allows instructors to engage with students directly in Eclipse. Instructors can send instant messages to students for issues that can be resolved easily, and they have the ability to do shared editing for more complicated problems. Let's look at a couple of scenarios that demonstrate the situations in which we imagine Hermes will be useful. Suppose a student is trying to concatenate two strings, but uses the wrong syntax and can't make sense of the compiler message, so decides to request help. An instructor can look at the student's console file and their code and quickly diagnose the problem. A brief message to the student should be enough to resolve their issue. Now imagine a student previously had a functioning sort routine, changed a few lines, and now no longer works. Frustrated, they request help. An instructor can look at the history of the file see where things went wrong, begin a shared editing session, and help the student resolve the issue.
All right, so the final point I want to make is I wanted to demonstrate that I had achieved my goal of proportional reuse by providing implementations of these other systems I'd mentioned. So I did implementation for the online IDE 1. To prove that this with minimal modification, the system can be used for different programming environments. And then I also did implementation for a microprocessor to kind of show this example of having a non-human in the loop. I think there's a lot of interesting applications for this with IoT.
Hermes was designed in such a way that it is in no way bound to Eclipse. It sends information about the programming environment using the XMPP protocol. So in theory, anywhere where an XMPP connection can be created, an implementation of Hermes can exist. For example, we have implemented an experimental version of Hermes that is a Chrome extension that works with online IDEs. The server side remains exactly the same as for the Eclipse version because the XMPP messages are exactly the same. Hermes is even more general. It doesn't have to be used as an educational tool. It is a tool for collecting data from many devices and aggregating this data in a useful way, as well as providing a way to communicate with the devices. To demonstrate this generality, we set up a microcontroller to work with Hermes. To show its capability of collecting data from a physical environment, we wired up a button. And to demonstrate its ability to receive information, we wired up an LED. When the button is pressed, it sends a message to the Hermes server. This information can be used to append a line to Google Doc, using the Google Docs extension we saw earlier. JSON can be sent to the microcontroller from any XMPP instant messaging client to control the LED.
All right, so the takeaway is what my talk title is. This is architecture for supporting opportunistic collaboration in general. So the point was to build a system that solved this goal problem of aiding in instruction and computer programming courses, while at the same time building a system that was flexible enough to be used in a lot of these opportunistic collaboration scenarios since they have a lot of overlapping components.